Welcome back. Now we'll talk about diameter distribution. We know that diameter distribution is closely associated with a normal forest. A normal forest is supposed to have a normal series of age gradations. Now, how we are going to assess the diameter distribution? In which diameter class we have how many number of stems? Stand contains types of all trees, all age classes and sizes. Normally, if you want to see a relation between the age classes, this is your age and this is your number of stems. We would expect that a curve should be like this, a straight curve. From a purely optimal view, if you from a purely optimal view, but what is actually we get a reverse J-shaped curve, the famous J-shaped curve given by Mayer in 1953, which can be illustrated as initially the in lower diameter classes the number of trees have to be very high, which over the period of time all these trees have to either suffer mortality or cutting, or have to face different kinds of eventualities which may reduce their number. So ultimately the number gets reduced with the increase in diameter. Now the J-shaped curve is based. This J-shaped curve is based on the work of a French forester named as Liocourt. Liocourt, he believed that the desirable diameter distribution in the stand could be described by the relationship. He gave a relationship that x number of trees in a particular diameter class is equal to q is coefficient, and x is the number of trees in the diameter class preceding to this diameter class. So between the two diameter classes, diameter class x td and diameter class x td minus 1, they have a relation which is the coefficient called as q, and q has a value greater than 0 and less than 1. How we are going to understand it? This is Liocourt's law. He believed that the percentage reduction in the number of stems from one diameter class to the next is constant. This is referred to as Liocourt's law. If the coefficient of series is known, now if we know the q, he gave a series like a comma aq minus 1, aq minus 2, aq minus 3, and so on up to aq minus n minus 1. If we know the coefficient, means q, if we know the coefficient of a series and we know the number of stems in any diameter class, maybe the coefficient here is a, and we know the number of stems q in any diameter class. A is the number of stems in the lowest diameter class, and q is the coefficient of reduction in the number. So yes, we got to have the value of q and the number of stems in any diameter class. Now the same formula of Liocourt was simplified by Mayer in 1933. He gave y is equal to k e raised power minus ax, where y is the number of stems in the diameter interval, x is the diameter at breast height, a is the percentage reduction in the number of stems in each diameter class, k is the relative stand density which may vary from species to species and forest to forest, and e is the base 2.7182 base of Neperian logarithm. This is the series, this is the coefficient, and a is the number of stems in the first age class. We are going to understand it further by taking this example. We have number of stems in the lowest diameter class, suppose it is given 10, quality class is q1, and coefficient of reduction in number of stems means q is 1.3. So we have to work out the series using Liocourt's law. How we are going to do that? We are going to do using the same formula that is given by Liocourt. This is the series of the entire forest for the given diameter distribution. Now here what is given? A is equal to 100, q is equal to 1.3. This is the series we are going to work out. Put the value of a in second. We know a is equal to 100. Now for the second we have a q minus 1. The value of a is 100. Put 100 into what is q, 1.3 raised power minus 1. So that comes out to be 77. When you solve this, it will come out to be 77. Now for the second one, AQ minus 2, similarly using the same figures, same given option, values, it is worked out to be 59, 46, 35. So you can see diameter distribution from 0 to 10 centimeter, 10 to 20 centimeter, 20 to 30 centimeter. Up till this, entire number of stems have been worked out. So as per Liocourt's law, the number of stems in the second diameter class, that is 10 to 20 centimeter, will be 77. So this is all about Liocourt's law. Thank you.